Hello and welcome to the lesson Combining Like Terms. Before we get started on our objective for combining like terms, please make sure you have a notes paper, and at the top of the notes paper, please complete the LOT. While you are completing that, please pause the video, and when you are ready to check your answers, please press play to resume and check your work. All right, welcome back. Let's take a look at this problem here. At the deli, Jackie bought P pounds of potato salad for $4.19 per pound. Write an expression showing how much Jackie will pay for P number of pounds. So I am supposed to write an expression. I remember that an expression is a math problem with no equal sign. I see that P is going to stand for pounds of potato salad. I also see the dollar amount $4.19 and the word per, which makes me think of multiplication. So I believe that for this problem, my expression is $4.19 times the P number of pounds. So 419P is my expression. In part B, it's asking me if she buys 3 pounds, how much will it cost? So it wants me to substitute in P equals 3 and see how much money it will cost if Jackie buys 3 pounds. So I'm going to do 419 times 3. 9 times 3 is 27. 3 times 1 is 3, plus 2 is 5. 3 times 4 is 12. 2 decimal places means that my decimal goes right there. $12.57 is my answer for how much it will cost. So let's take a look at our objective here today. Our objective is that mathematicians will be able to combine like terms in order to simplify expressions. Again, expressions do not have equal signs, so I'm still looking at expressions here. Before we go further, I would like you to pause the video and make a quick list of anything you remember from last year about like terms. When you have some things down on your paper, please get at least 2. When you have at least 2 or 3 things on your paper for what you know about like terms, then you can press play and check your work. All right, welcome back. Let's continue with our lesson here and see what you have that matches. So first we have some vocabulary words. Again, you should be following along on your notes paper. Our first vocabulary word is the word expression. An expression is a number sentence with numbers, variables, and operations, but no equal sign. So I remember an equation has an equal sign, an expression does not. So, for example, I have 2x, and these are listed at the bottom. 2x is an example of an expression because it does not have an equal sign. 3x plus 9 is an expression. 3 plus 9y, 5 plus 8. Notice I do not always have to have variables. I remember that this 5 plus 8 is also an expression. It is just a numerical expression rather than an algebraic expression. Another vocabulary word I need to be familiar with is the word term. When I am thinking about a term, I am looking at the pieces of my problem that are separated by the plus or minus signs. So as I look here, I see a plus sign here and a minus sign here. So the terms are everything that is separated by that. So 2x is my first term, 3y is my second term, and 1/4 TP is my third term because it is anything separated by those plus or minus signs. So in this specific example, I have 3 terms. Next, I'm going to look at the vocabulary word coefficient. A coefficient is the numerical part of a term that contains a variable. It having a variable is key information. A more simple way to refer to that is the number before a letter. So as I am looking at my same example here, I am looking at the 2 in front of the x, the 3 in front of the y, and the 1/4 in front of the TP. Those are my coefficients, the numbers before letters in my terms. As I continue on here with my vocabulary, I have a constant. I think of constant as something that is not changing, and when I have a number by itself, a term with no variable, that value is not changing. It's not being multiplied or divided by anything at this point. So, for example, the number 4, -5, 20, 41, they are all constants because they do not have a variable with them. Then I have the word variable. The word variable is a letter that represents an unknown number in a math problem. Remember, it's not just because we're trying to throw letters into math to make it confusing. That letter, that variable, represents something that we just don't know at this time. So, for example, in the problem below, our variables are x, y, and the letters t and p. So any letter, any variable in the problem is standing for something that we do not know yet. We also have the vocabulary word like terms. Like terms are terms that have the same variable. So remember, a term is separated by a plus or minus sign. So when I'm looking at those separated terms, I'm looking for items that have the same variable. For example, 3x and 2x are like terms. 15y and -7y are like terms. And in this last example here, separated by plus or minus signs, so this is a term, this is a term, and this is a term. However, they do not all three match together. The 12m matches with the -4m, but the positive 18 does not match up with the 2m's because it does not have the same variable. So, can you identify those pieces of these three expressions here? Please pause the video in just a moment, and I want you to underline the terms, circle the coefficients, and put a box around the constants. So underline the terms, circle the coefficients, and put a box around the constants. Please pause your video and do that now. All right, welcome back. Let's go over our answers here. When I'm identifying terms, again, looking for anything separated by plus or minus signs. So 2 is a term, 6a is a term, and 4a is a term. For my coefficients, I'm supposed to circle my coefficients, and I know that a coefficient is the number before a letter. So the first value, the number 2, does not have a variable, so it is not a coefficient, but 6 is because it's in front of the letter A, and 4 is also because it is in front of the letter A. 2 in this case is a constant because it is a value with no variable. In the second one, 4r is a term, -5s is a term, +5s is a term, and -2r is a term. 4 is a coefficient, -5 is a coefficient, +5 is a coefficient, and -2 is a coefficient. And in number 2, I do not have any constants. I have no numbers that are missing variables, no numbers that do not have variables. In the last one, 5h is a term, -3g, +3g, and -h are my 4 terms. 5 is my coefficient here, -3, +3, and here is my coefficient. Even though I don't see a number there, I need to remember that in front of every variable there is an invisible number 1, especially if there is no number there. So my coefficient for the h on the end there is -1. Once again, in this third one, I do not have any constants. So now, on the right side of your paper, can you take these same 3 expressions and identify any like terms that you see? All right, so let's check it out. As I look at number 1, I see the number 2 to start off my expression. However, I do not see any other values that don't have a variable, so I do not think that that is a like term to anything else. However, I see 6a and 4a. They have the same variable of the letter A, so those would be my like terms. In number 2, I see a couple sets of like terms actually. 4r has the same variable as negative 2r, so those would be considered to be like terms. And also the middle two terms have s's, so negative 5s and positive 5s are like terms. In number 3, 5h is a like term with negative h, and negative 3g is a like term with positive 3g. So how does this help me combine like terms to actually work on my objective here of mathematicians being able to combine like terms to simplify expressions? So as I look here, I see 4 terms, 2x, 4, 3x, and negative 1. And as I look at those, I want to look for items that have the same variable. So 2x has the same variable as positive 3x. 4 and negative 1 have the same variable or lack of variable. So I'm going to combine 2x plus 3x, and then I'm going to combine positive 4 minus 1. If I have 2x in one hand and 3x in the other, altogether I have 5x. And then positive 4 minus 1 is positive 3. So when I combine like terms in this problem, I have 5x plus 3. Now before we continue to the next problem, I want to point out these shapes that I have been drawing around my like terms. It is an extremely helpful tool to put similar shapes around like terms. What that allows us to do is it allows us to picture the terms that are actually connected, actually related, and have the same variable. So when we look at this one here, I see a couple different things. I see a variable of t, so I'm going to look for anything else with a variable of t, and I see that here. Then I see negative 9 and negative 1, two terms without variables, or two constants. So when I combine 6t plus 2t, I end up with 8t. And when I combine negative 9 and negative 1, I see that when I do keep, change, they are the same sign, so I add and keep the negative, so I have 8t minus 10. Go ahead and pause the video and give this problem a try, and when you are ready to check your answer, please press play and give it a check. Alright, welcome back. Q and Q go together, 3 and 4 go together, so I have 5Q minus, that invisible 1 is there, 5Q minus 1Q is 4Q, and 3 plus 4 is 7. So how does this relate then when I have something more like this? When I have like terms, I am looking for terms with the exact same variable. So as I look here, 6x squared, I'm looking for anything else that has an x squared, and I see that here. Remembering that there is an invisible 1 in front there. I do not see any other x squared, so I'm going to move on. I see x and y together, and as I look through my other terms, I see a plus 3xy at the end, both having the same variable, so they are like terms. And then I have negative 2 here in the middle. I do not have any other constants, so that will remain by itself, which means it's not going to change. 6x squared plus 1x squared gives me 7x squared. xy plus 3xy, again remembering there's an invisible 1 in front there, gives me a positive 4xy. And then the negative 2 had nothing else to combine it with. There were no other constants, so I bring that to the end of my expression. Again, looking for the exact same variable. Negative 3ab. Looking for anything else that has an a and a b together, and I see that here. Then I move on to the letter b. I see another b here at the end, and then I have negative a and negative a. You'll notice that as I have been putting these shapes around like terms, I have been including the sign in front of it. That is important. I cannot just assume that everything is positive and add them together. I must bring the sign that was in front of it along with the term. So negative 3ab plus 2ab. In this case, I see that one is negative and one is positive, and so I am actually going to end up subtracting. I'm going to think about 3 minus 2 is 1. However, 3 is larger than 2, so I'm going to end up with negative 1ab, which is the same as leaving the 1 out and having it as negative ab. Now that I've taken care of those, I'm going to move on to my variable of b. I have plus b and plus 9b, again remembering that invisible 1, so I have 10b altogether. And then I have negative a and negative a. Both of them have a 1 in front, and they both are negative. So when I have the same sign, I am going to add the two together and keep the sign as negative 2a. Now what you'll see here on my bottom two lines, I have two separate forms of the same expression. And the only difference is that in the top one, I wrote the 1, and in the bottom one, I left it as the invisible one. So kind of just keep that in mind. All right, if you would take a moment and give yourself a self-rating on your paper, where do you think you are right now? 1, you're still confused and need lots of help. 2, you're almost there but getting a little bit stuck. 3, you think you're rock solid. Or 4, you think you could help somebody else in the class. Please just take a moment and rate yourself on your paper. And let's do a couple more. Now, when I first look at this problem, it makes me nervous, but I know that I can break it down by finding my like terms. And I'm going to start with 3x squared y. I notice that in this first term, I have an exponent on the x and no exponent on the y. It's extremely important with like terms that the exponents and everything about the variables perfectly matches. So as I look through the rest of my expression, I'm looking for something that has an exponent of 2 on the x and no exponent on the y. And as I look through, I do not see that. So 3x squared y is going to become part of my answer. As I continue in my expression, I now see 2y squared x, but I notice that the exponent is on the y instead. I don't see any other exponents in my expression, so this term is also simply going to copy to my answer. Next, I have 2x, which is positive, and negative 6x. I see that they are different signs, so I am going to end up subtracting, which gives me 4x, but 6 is larger, so it's a negative 4x. And then I have negative 3 and positive 2. Again, different signs subtract using the sign of my larger number, which is 3, so I have a negative 1 at the end. This expression, while it does not look simplified because it is still rather long, it is as simplified as we can make it because nothing else has the same variable. So let's step it up a notch here real quick and take a look at decimals. What happens if we have decimals in these expressions? Well, do not panic because it is exactly the same idea. In this expression, I see that both values have the variable of k in them. So I'm going to treat it just like they're like terms because they are. I see that it is subtraction, so I'm going to do 6.1 minus 5.3. And I'm left with 0.8k. Go ahead and pause the video and give this decimal question a try. And either when you get stuck or when you get to an answer, press play and check your work. All right, welcome back. As I look here, I see a constant of 9 and a constant of -7. So right off the bat, I am thinking 9 minus 7, and that gives me 2. So that's the first piece of my combining like terms. Then I see negative 7.88x and positive 1x. So what I'm going to do here is combine these, but because they are different signs, I'm going to subtract. 7.88 minus 1. Now I have to be careful with that 1 to add the decimal at the end and make sure I line those up. And I end up with 6.88. However, in my original expression, I see that the 7.88, which is the larger number, was negative. So I'm going to have negative 6.88x as the second piece, the second term of my answer. So 2 minus 6.88x. In the last question, we of course have fractions. Remember, we do not want to panic when we have fractions. We want to remain calm and break it apart with what we already know. So I see 1/2 b and 6 over 5b. I see that they both have the variable of b, so that's nice. I have like terms and I need to combine them. However, it is an adding problem, so I have to find a common denominator first. When I'm thinking about the numbers 2 and 5, I notice that the common denominator is 10. So I'm thinking 2 times what gives me 10, and that is 5. So I also need to multiply 1 times 5, and that will give me 5/10 b. The second one, it's 5 times 2 equals 10, so I'm going to do 6 times 2 equals 12. And now I need to add my numerators. 5 plus 12 is 17. My denominator stays the same. And for today, it is okay if you leave it as an improper fraction. However, if you did convert it to a mixed number, it would be 1 7/10 b. Both of those answers would be just fine. All right, so hopefully by the end of this lesson, which is now, you feel more comfortable and confident on combining like terms. Please show your completed notes paper to the teacher to receive the homework assignment. You may refer back to your notes paper as you are working, and you may check with your table group if you need to, as long as you are not distracting other students. If you do not complete the practice page, it is homework.